This is section 3.3. So let me go ahead and share the screen and show you the problems. 3.3, we have to do 3 to 65 odd. So we're on page 309, it looks like. So polynomial division there. Next page. Long division. Synthetic division. So read what the text has about synthetic division. That's up to about 41. Gives you up to 51. 53, 61. Okay, and that's up to 65, which is as far as we had to go. All right. Okay, problem 5. Divide this by this. So take the first thing here and the first thing here, as soon as I can get this thing focused. What do you multiply 2x by to get 4x squared? It's 2x. Now 2x times this whole thing, 4x squared minus 2x. Subtract, that cancels out. Negative 3x minus a negative 2x is a negative x. Bring down to negative 7. What do I multiply 2x by to get negative x? It's negative a half, a little bit awkward. Negative a half times this whole thing. Negative x plus a half. Subtract. Negative x minus a negative x is 0. Negative 7 minus a half is negative 7.5 or minus 15 over 2. So final answer 2x minus a half minus 15 over 2 divided by 2x minus 1. Remainder over the original divisor. 13 illustrates that if you have any missing terms, you got to count them as zeros. So the original had this. It stopped at 8x squared, 6x squared. So in order to complete the division, I need 0x and 0. Likewise here, 2x squared plus 1, sneak in a 0x here. Now it's the same as before. How do you go from here to here? 4x squared. Now 4x squared times this whole thing, 8x to the fourth, 0x cubed, 4x squared. Subtract, that cancels out, 4x cubed plus 2x squared, bring down to 0x. Start over. How do you go from here to here? 2x. 2x times this whole thing, 4x cubed plus no x squared plus 2x. Subtract, that's gone, 2x squared minus 2x, bring down to 0. How do I go from 2x squared to 2x squared? Multiply by 1. So 1 times this whole thing, well, it's just that whole thing. 2x squared plus 0x plus 1, subtract, cancels out. Negative 2x minus 1 is my remainder. So plus a negative 2x minus 1 over 2x squared plus 1 is my answer. 19, the original had x cubed plus 2x plus 1, sneak in a 0x squared. How do I go from x squared to x cubed? Multiply by x. X times this whole thing, x cubed minus x squared minus 3x, subtract. That cancels out. 0 minus a minus 1, x squared. 2 minus a minus 3, 5, bring down to 1. How do you go from x squared to x squared? 1. 1 times that, well, it's just that. Subtract, that cancels out. 5 minus a negative 1 is 6. 1 minus a negative 3 is 4. That's my remainder. So 6x plus 4 divided by x squared minus x minus 3. Okay, this is now illustrating synthetic division. Okay, it's a much more compact way of dividing. Synthetic division only works on first degree polynomials that you're dividing by. So in other words, x plus 1, x minus 5. You cannot do synthetic division if you're dividing by a squared term or a cubed term or whatever. Only when you're dividing a linear term. Okay, a linear expression like x plus 1. So I just put the coefficients 3, 1, and 0. 0 is the constant. And if I'm divided by x plus 1, you put negative 1 here. You change the sign of this. Another way to think of it is what number makes this 0? -1. -1 goes there. Okay, bring the first coefficient down, 3, and then you're just going to do a lot of multiplying and adding. So I multiply, -1 times 3 is -3, add -2. Do it again, multiply, -1 times -2 is 2, add. This will be my remainder. And so how do I read this off? Read this as 3x minus 2 plus 2 over x plus 1. And so this is synthetic division. Notice we're just not putting all the x's and x squared. It gets very cumbersome. We know they're there, but we just decide not to put it until the very end. 35. This was 2x cubed plus 3x squared minus 2x plus 1. Just put 2, 3, -2, 1. Dividing by x minus a half means I put 1/2. Bring the 2 down. Multiply, add, multiply, add, multiply, add. So I read this as 2x squared plus 4x plus nothing, so I don't have to write the nothing, plus 1 over x minus a half. 37, x cubed minus 27, x cubed plus 0x squared plus 0x minus 27. Divided by x minus 3 means I just put a 3. 1. Multiply, add, multiply, add, multiply, add. No remainder. So how do I read this? X squared plus 3x plus 9. Okay, when I do the synthetic division, the original polynomial is depressed by 1. So it used to be 3rd degree, now it's 2nd degree. If it used to be 2nd degree, then it would become 1st degree, and so on. 43, find p of -2. What happens when you plug in -2? So the polynomial is x cubed plus 2x squared plus 0x minus 7. Okay, so 1 comes straight down, multiply, -2, add, multiply, add, multiply, add. This is the remainder, which is also the value of p of -2 by the theorem. So p of -2 is -7. 49, find p of 2/3. Coefficients 3, 4, -2, 1. 3 comes down. Multiply, 2/3 of 3 is 2, add. Multiply, 2/3 of 6 is 4, add 2. Multiply, 2/3 times 2 is 4/3, add them up, 7/3. So p of 2/3 is 7/3. 55, is x minus a half a factor of the original polynomial? It will be if my remainder upon synthetic division is 0. So let's try it. 2, 7, 6, -5. 2 comes down. Multiply, 1, add. Multiply, half of 8 is 4, add 10. Multiply, half of 10 is 5, add 0. Yes, p of a half is 0. Therefore, the factor theorem says x minus a half is a factor of the original polynomial p of x. '61, okay, trying to show that -2 and -3 are zeros of the original polynomial. 3, -8, 14, 31, 6. Okay, this is units, x's, x squared, x cubed, x to the 4th. Okay, synthetically divide. 3 comes down, multiply, add. Multiply, -14 times -2 is 28, add 14. Multiply, -28, add 3, multiply, -6, 0. That proves -2 is a 0 of the original polynomial. Okay, and now to save time, this means 3x cubed minus 14x squared plus 14x plus 3. Just synthetically divide on this. You don't have to go back to the original, just start with this again. So 3 times 3 is 9, -5. 3 times -5 is -15. -1. 3 times -1 is -3, 0. So that proves 3 is a factor of the original also. So p of x, the original polynomial, I can now write as x plus 2, x minus 3, and 3x squared minus 5x minus 1. And if you want the rest of the zeros, use the quadratic formula. So -b plus or minus the square root of b squared, 25 minus 4 times a times c, which is -1. All over 2 times a, 2 times 3, which is 6. That's 25 plus 12. So 5 plus or minus radical 37 over 6. So the original was a 4th degree polynomial. There are 4 roots. Here they are, -2, 3, and 5 plus or minus radical 37 over 6. Okay, finally 65, you're reverse engineering, you're going backwards. Come up with a polynomial, which is degree 4, with the zeros of -1, 1, 3, and 5. Basically, all you do is just x minus each of these, x minus a -1, x plus 1, x minus 1, x minus 3, x minus 5. Done. Okay, it's very easy to check that all of these gives you 0. Plug in -1 to all 4 of these. -1 plus 1 is 0, so that wipes the rest out. If you plug in 1 here, 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 and here, well, this one's 0, and 0 times the rest is 0. If you plug in 3 here, 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 and here, this one's 0, so 0 times the rest is 0. And likewise, if you plug in 5 here, 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 well, 5 minus 5 is 0, so you don't care about all that. The answer is going to be 0. Okay. All right, so that pretty much does it for section 3.3.